Section 6.4, continued. We'll pick up where we left off. Last time we were adding and subtracting rational expressions that either had a common denominator already or the denominators were opposites. Now we're going to take a look at some more general cases. Let's start with a numeric example. Let's say I want to add 1/10 plus 1/15. In order to add fractions, I need a common denominator. I prefer using the least common denominator. The least common denominator for 10 and 15 is 30. Now question, how do I find that least common denominator algebraically? How do I determine the least common multiple of 10 and 15? Well, I can do it by factoring. 10 is 2 times 5, and 15 is 3 times 5. To find this least common denominator, I take every different factor I see the most number of times it appears in any one denominator. I see factors of 2 and 3 and 5, each appearing no more than once in any single denominator. So my least common denominator is 30. How do I change these to have that common denominator? Well, I ask, what's missing? What's missing out of this 10 to turn it into a 30? It's already got a 2 and a 5. What's missing? A factor of 3. We multiply that top and bottom. That way we're multiplying by 3/3, which is 1. When you multiply by 1, you may change the way it looks, but you don't change the value of that fraction. And for my 15, what's missing? The 15 contains a 3 and a 5. What's missing? A factor of 2. Top and bottom. Now that mechanically is how you go about finding the least common denominator and changing your fractions to have that common denominator. So we now have what? 3/30 plus 2/30, a total of 5/30, and then of course at the end we reduce if needed. This reduces to 1/6. So this is the idea we're going to be using to add and subtract these rational expressions when the denominators are different. Let's look at a blue box. Once again on page 417, adding rational expressions with different denominators. Now, this will apply, of course, to subtraction as well. Step 1, find the least common denominator. That's what we did here with the pink marker. And we use the factors of my denominators to discover that. Find the LCD. Step 2, rewrite each rational expression as an equivalent rational expression with the LCD as its denominator. That's what we did here in blue and into the next step. We changed our fractions to both have that common denominator. Now once you have a common denominator, you add the tops, write that result over this common denominator, and finally, step 4, reduce to lowest terms. So we've seen it numerically. Let's have a look at this and slowly build our way up to some of the more difficult problems here in these rational expressions. Let's start off fairly simple. Number 30. I want to add these rational expressions. They have different denominators. So I need to know what is the least common denominator. Now if I want to, I can do this by factoring. 8 ends up factoring into 2 times 2 times 2. and 5 is prime, so it's just 5. So my least common denominator, take each different factor you see, the most number of times it appears in any one denominator. Well, I see factors of 2, and at most, the 2 appears 3 times. I could write 2 cubed. At most, it appears 3 times. I also see a factor of 5. My least common denominator here is 40. Now I change my denominators to be that least common denominator by asking what's missing. When we find the LCD, we're discovering what can these both be turned into. And then we ask the question, what's missing? What turns 8 into a 40? It needs a 5. What turns 5 into 40? We need an 8. And so let's rewrite our rational expressions now with these new denominators. P times 5 is 5p. That's now over 40. Plus 4 times 8, 32 over 40. We now have rational expressions with a common denominator. We add the tops, 5p plus 32. Those are unlike terms, so the best I can do is write 5p plus 32 over this common denominator. Now check for lowest terms. Is this numerator factorable? There's no greatest common factor I can pull out, and there's nothing else I can do. So we have this single factor in the top. We have this numeric factor in the bottom. Nothing will cancel, and so that's in lowest terms. Let's try number 38. So first let's figure out what our least common denominator is. And again, I'm going to show this by factoring because I want to get used to the idea of looking at the factors. 4 is 2 times 2. 6 is 2 times 3. And I want to know, what is the least common denominator? The least common denominator is found by taking every different factor I see 2s and 3s, the most number of times it appears in any one denominator. So I see factors of 2, and at most it appears twice in this first denominator. So 2 squared, or 2 times 2. There are a couple of 2's in my least common denominator. I also see a factor of 3, and at most it appears once in any single denominator. So my greatest common factor here, I know we can look at the 4 and the 6 and we know it's 12. But I want to look at this idea of how we can use the factors to find the LCD for when we get to these problems where we're dealing with polynomials for denominators. Knowing that my least common denominator is 12, I've answered the question, what can both of these denominators become? What can they both be turned into? Now I ask the question, what's missing? What's missing from this first denominator to turn it into a 12? Well, it's missing a factor of 3, top and bottom. And what's missing from this second denominator? What turns 6 into a 12? It's missing a 2. Now we simplify the numerators. And look very carefully here. You know the fraction bar is a grouping symbol. You know the fraction bar is a grouping symbol. So it is this whole 2x minus 6 that I'm multiplying times that 3. What does that tell you? It tells you we're going to have to distribute. It's as though we have parentheses there because of that fraction bar. The fraction bar is a grouping symbol. It'll be the same over here. And so we need to distribute this 3. That will give me 6x minus 18. That's all over 4 times 3 is 12, our common denominator. And distribute this 2 to get 2x plus 10 over that common denominator. 6 times 2 is 12. Now we have rational expressions with the same denominator. We're ready to add the tops, which is why we needed them simplified. If I'm going to be combining like terms here in the numerators, I've got to have my numerators simplified. Combining like terms in these numerators, we will get 8x minus 8, and that's all over 12. Are we done? That numerator is factorable. I'd better check for lowest terms. We can factor out an 8. We can factor out an 8, leaving x minus 1. And now, what do you see? You've got an 8 up top, a 12 on the bottom. They both contain a 4. 4 goes into 8 twice. 4 goes into 12 3 times. And so this reduces to 2 times the quantity x minus 1, all over just a 3. It is generally preferable to leave our answers in factored form in this chapter when we're dealing with rational expressions. However, occasionally you may look it up in the back, and for one reason or another, that too may be distributed back in. Just be able to recognize that these two answers are the same, but there is absolutely nothing wrong with leaving your final answer in this factored form. Okay, let's turn it up just a little more. Let's throw some variables in these denominators. Number 42. I'm subtracting rational expressions with different denominators. So the first thing I need is the least common denominator. I find my least common denominator by taking every different factor I see, the most number of times it appears in any given denominator. So, there's nothing I can do about factoring these. They're factored completely. Let me just look at what factors I have. I see a factor of 5. And I also see a factor of m, and the m at most appears twice in that first denominator. So my least common denominator is going to be 5m squared. Now we ask the question, what's missing? And of course in this first denominator, he's already ready to go. He's already that 5m squared. My second denominator though, what's missing? I have a single m. I need a factor of 5 and one more factor of m to turn this into 5m squared. So we have 12 over 5m squared minus 25m over 5m squared. We're ready to subtract. I don't think it's as critical here, but I'm going to stay in the habit of giving that negative to the second numerator. It's a single term, so I don't really call it distributing. But I'm giving that negative to the second numerator just to keep myself out of trouble. We're ready to add these numerators. They are unlike terms, so we have simply 12 minus 25m. And that's all over this common denominator. That numerator is not factorable any further, and there are no factors common to the top and bottom. So that is in lowest terms. Number 46. Now, I've seen students look at a problem like this and say, well, I just need one more x in this first denominator and I'll have a common denominator. Well, you can't just shove one more x in there without distributing, which would make it a much different denominator than that second fraction. Let's follow the steps. We want to find a common denominator. To find a least common denominator, we collect factors. If I'm collecting factors, I need to see all those factors. So I need these denominators factored. This first denominator is prime, meaning he cannot be factored any further. Now leave you a little space here. For our blue marker, when we say what's missing, I'm going to need me a little room right here. Plus, and in my second fraction, the second denominator is a difference of squares. It will factor as the first plus the last times the first minus the last. Now that I can see the factors, now let me figure out what is my least common denominator. I take every different factor I see, the most number of times it appears in any one denominator. I see factors of x plus 1 appearing no more than once, and factors of x minus 1 appearing no more than once in any single denominator. So my least common denominator, answering the question, what can both of these denominators become, is x plus 1, x minus 1. Now we ask the question, what's missing? What's missing from this first denominator to turn it into my least common denominator? I already have an x minus 1. I just need an x plus 1. What's missing out of my second denominator? Well, nothing. That's already the denominator that I'm after. We now, strictly speaking, have a common denominator. We need to get ready to add these numerators. We do that by simplifying the numerators so that in a moment we can combine like terms. Distribute that 2x. That's going to give me 2x squared plus 2x over. Now, as these denominators get bigger and bigger, I tend to get lazy. And instead of writing x plus 1, x minus 1, here in these intermediate steps, I'm just going to abbreviate and say that's over my LCD. It's the same thing as writing x plus 1, x minus 1, but just a lazier version. And plus is negative 4 over, well, my LCD. Now this abbreviation is fine in intermediate steps. However, it is certainly not appropriate to use this abbreviation in a final answer. If you put LCD in a final answer, I'm going to count it wrong. In a final answer, I need to see what the actual algebraic denominator is. Okay, so we have a common denominator, we have simplified numerators. Let's keep going. We're going to add the tops. And I'm going to need more room. So let me start again here at the top of the board. Add these numerators. They are all unlike terms. Now, it is possible that this is our final answer. And so I'm going to restore, instead of using my abbreviation, I'm going to restore the actual common denominator, x plus 1, x minus 1. But now I have to ask, am I done? Am I done? Or can these be reduced to lower terms? Well, let's see. I certainly can factor out a 2 in this numerator. can that be factored any further? Well, if that trinomial will factor further, it will factor as a pair of binomials, each starting with x. Signs are opposite. Product of -2, sum of 1, it's got to be -2. I'm sorry, it's got to be -1 and +2. The larger had to be positive, right? And it's a good thing we checked, because it was not in lowest terms. I have a common factor that I'll strike out, and canceling that will leave me 2 times the quantity, x plus 2, over x plus 1, which no longer needs his parentheses because he's the only factor in that denominator. All right, let's do another one. Number 48. And remember, the steps of this process are the same whether I'm adding 1/10 plus 1/15 or some crazy thing like number 48. Now, honestly, number 48 is kind of what I think of when I think of this section. I consider number 48 to be one of the quintessential problems when we talk about adding and subtracting rational expressions. And it's a problem like this that makes me miss the whiteboards in the classroom, because this is going to take some space. Let's see how this goes. I want to add these rational expressions. They have different denominators. I need to find the least common denominator. To find the least common denominator, I need to collect factors. Let's get these denominators factored. If this first denominator factors, it will factor as a pair of binomials, each starting with a. Signs are opposite. Product of -4, sum of +3, it's got to be 4 and -1. Leave you some room here where we can ask the question, what's missing? And plus, if this second denominator factors, it will factor as a pair of binomials, each starting with a. Signs are the same. In fact, they're both plus. Product of 12, sum of 7. It's got to be 3 and 4. Now that I can see all the factors, let me find my least common denominator. Collect every different factor you see, the most number of times it appears in any one denominator. I see factors of a plus 4, a minus 1, and a plus 3, each appearing no more than once in any given denominator. Now that I've figured out what my least common denominator is, I ask the question, what's missing? What's missing from this first denominator to turn it into my least common denominator? It's missing an a plus 3, top and bottom. And what's missing from this second fraction? From that second denominator, it needs an a minus 1, top and bottom. Now we need to simplify these numerators. Strictly speaking, we now have a common denominator, but to add these numerators, I need to combine like terms, which means I need both of these numerators simplified. A times a plus 3. Well, I'm going to distribute that a to get a squared plus 3a over this, right, over this common denominator, plus distribute this 4a to get 4a squared minus 4a over this common denominator. Now that the numerators are simplified, I'm ready to combine like terms. I'm ready to add those numerators. That'll give me 5a squared and minus a all over Now this could be my final answer. So let me not use my abbreviation, but let me actually write the algebraic denominator back in place. Now, we need to ask, is this in lowest terms? If you think ahead, the only factoring I can do in this numerator is to factor out an a. Factor out a greatest common factor of a. And what will that leave me? A 5a minus 1. Doesn't match anything on the bottom. If you can see that far ahead, you are welcome to put a box around this. If you want to be absolutely certain that you're not missing anything, put a box around this if you have absolute confidence. But let me make some room up here above. But if there is any doubt in your mind, go ahead and show it in factored form. Factor that numerator. And then we can plainly see that no, there is nothing here that will cancel. We went to all the trouble to factor it. Might as well leave it factored in my final answer. And on a problem like this, when you turn to the back of the book and check your answer, it will most likely be in factored form. But if you have absolute confidence that you can see ahead enough that even factoring this numerator will not give you any factors that will cancel, you are welcome to go ahead and box it right there. But there's also nothing wrong when dealing with rational expressions, nothing wrong leaving my answer in factored form. Number 50. I need to subtract these two rational expressions that have different denominators. So the first thing I need to find is my least common denominator. I find that by collecting factors. Let's get these denominators factored. This first denominator is a difference of squares. It will factor as the first plus the last, the first minus the last. Leave you some room right here for what's missing. Minus this second denominator. Did you spot it? That might be a difference of, that might be a perfect square trinomial. It starts with a square and it ends with a square. The squares of x and 4. Is this thing in the middle double x times 4? Is it double 4x? It sure is. And so this will factor as the first, and in this case plus, the last quantity squared. Now, if you factor that by saying it's going to be a pair of binomials, each starting with x, signs the same, they're both plus, product of 16, sum of 8, how about 4 and 4? Nothing wrong with that. You will still have two factors of x plus 4 in this denominator. And I'm not concerned about which way you write it here in an intermediate step. In a final answer, it's nice if you go ahead and take this and collapse it down to that binomial squared. But as an intermediate step, no big deal either way. We have these both factored. So we look for our least common denominator, collecting every different factor I see, the most number of times it appears in any one denominator. I see factors of x plus 4 and x minus 4. X plus 4 appears at most twice in one of these denominators. So x plus 4 quantity squared. And x minus 4 appears no more than once. So here's my common denominator. That's what both of these denominators can be turned into. And so now we ask, what's missing? What's missing from this first denominator? Well, I have an x plus 4, I have an x minus 4, I just need one more x plus 4. Out of my second denominator, what's missing? I've got both of my x plus 4s. It just needs an x minus 4. Strictly speaking, we have a common denominator now. It's about time to subtract my numerators. To do that, I'll be distributing the negative, combining like terms, so I need both numerators simplified. Distribute this 2x. That will give me 2x squared plus 8x over this common denominator minus, distribute to 3. 3x minus 12 over this common denominator. To keep myself out of trouble, I am going to give this negative to that second numerator. Let me distribute this negative through that second numerator, which, I mean, if I'd been paying attention, I could have distributed what? The negative 3 and already had that part done. But let's not take too big of bites. Okay? Little steps, little pieces, and that'll keep us out of trouble. So, we're ready to add now these numerators. Combine like terms. We have 2x squared and plus 5x plus 12. And that's all over this common denominator. Now, again, this may be my final answer. So let me not use my abbreviation, but let me rewrite my actual algebraic denominator. Is this in lowest terms? Is this numerator factorable? I told you back in section 5.3 that the AC method was very convenient in chapter 6, and it's for cases like this. My AC method can very quickly determine if this numerator is factorable. Okay? AC method says I'd be looking for two numbers whose product was a times c, 2 times 12 is 24, and whose sum is 5. Go down the list. 1 and 24? No. 2 and 12? No. 3 and 8? No. 4 and 6? No. And I'm out of factor pairs. Right? We went down the list. 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 doesn't work. 6 has already been discovered, so I'm out of factor pairs. That numerator is prime. And I very quickly determined that that was prime using my AC method. Meaning that this is in lowest terms. Nice. Let's do one more. Let's crank this one up just a little bit above what we've been doing. Number 72. Actually, number 72 falls right in line with the last two problems that we've worked. It's just that my numbers are cranked up a little bit. We also have binomial numerators. It will be interesting to see what that might do in working one of these problems. All right, we need an LCD. We need to get these denominators factored. If this first denominator factors, it factors as a pair of binomials. It's got to start 2y and y. Signs are opposite. I may have those in the right place or not. We'll figure that out. And the only way a 3 falls apart is 1 and 3. So is it 1 and 3 or is it 3 and 1? How about 1 and 3? Check the outside and the inside. Nope, that gives me a negative 5y back in the middle. So swap my signs, I should be good. Let's double check. There's my 2y squared. The last, yep, negative 3. Outside and inside, plus 6y minus y plus 5y. All right, so we got that factored. Leave you some room for what's missing. And minus. If this denominator factors, it will factor as a pair of binomials, each starting with some y term. Signs are opposite. It's got to be a 1 and a 2. My signs may or may not be in the right place. Now, how does that 6 fall apart? Is it 6 and 1, 1 and 6, 2 and 3, 3 and 2? Well, I know I can't put an even number over here in my second factor. That would create a magic greatest common factor. So is it a 1 here and a 6 there? No, certainly not. That would give me minus 11y back in the middle. Nowhere close to what we're looking for. So how about 3 and 2? And the 3 has to go there, so I don't create a magic greatest common factor. Double check that. That's minus 4y plus 3y. All I need to do is change my signs. Check this one more time. I get my 6y squared back as my first. The last gives me my minus 2. That works. And for the middle, plus 4y minus 3y is plus y. So that's how that factors. Now let's find the least common denominator. We find the least common denominator by gathering every different factor we see, the most number of times it appears in any one denominator. We see factors of 2y minus 1, y plus 3, and I'm running out of room, 3y plus 2, each appearing no more than once in any given denominator. So that's my least common denominator. And we go through now and ask, what's missing? What's missing from this first denominator to turn it into that least common denominator? I've got my y minus 1, I've got my y plus 3. It's missing a 3y plus 2. What's missing from my second denominator to turn it into my least common? I've got my y minus 1 and my 3y plus 2. It's missing a y plus 3, top and bottom. Strictly speaking, we now have common denominators. We're almost ready to subtract by distributing the negative and combining like terms. But before we do that, I need what? I need the numerators simplified. Well, I have what? A binomial times a binomial. We know that this fraction bar is a grouping symbol, so it's as though I have parentheses there, likewise in the second case. So in order to simplify these numerators, I'm going to have to FOIL. So here we go. Product of the first, 4y times 3y is 12y squared. The outside and the inside. The outside plus 8y. The inside minus 3y for a total of plus 5y. And product of the last, minus 2. And that is over this crazy least common denominator. Minus, we've got to FOIL this out. Or if I recognize this is y plus 3 quantity squared, I can use my special product. Either way, we'll get y squared plus 6y and plus 9. Whether you FOIL that or use your special product, that's the trinomial that results. And that's over this least common denominator. So the numerators are simplified, which this time required that I FOIL. I'm about ready to combine like terms. First, I want to distribute this negative. To subtract polynomials, we distribute the negative, combine like terms. In other words, I'm going to give this negative, as I always do, to that second numerator, and now combine like terms. Let me make some room here at the top of the board. And let me keep my LCD up where I can see it, because All I have left now is the abbreviation. So as I combine like terms here in these numerators, 12y squared minus y squared is 11y squared. Plus 5y minus 6y is minus y. Minus 2 minus 9 is minus 11. Now, this could be my final answer. If that numerator won't factor, this will be my final answer. So let me not use my abbreviation, but actually write this crazy least common denominator back in place. Now the question is, are we done? Is that in lowest terms? Well, will that numerator factor? Will that numerator factor? If it will factor, I'd be looking for two numbers whose product was a times c, negative 121, and whose sum was negative 1. Well, the factor pairs for 121, 121 is 11 times 11. 11 is prime. There's not going to be a bunch of factor pairs. It's either 1 and 121, the larger one being negative. That doesn't add up to negative 1. The next thing that will go into 121 is 11. 11 times. That doesn't add up to negative 1. So there are no two numbers whose product is negative 121, whose sum is negative 1. This numerator then is prime. And very quickly finding that out, I'm ready to say this is my final answer. It is in lowest terms because I discovered that that numerator could not be factored. And that AC method really helped me determine that fairly quickly. All right. So adding and subtracting rational expressions, just like adding and subtracting fractions, but a little bit heavier problems now, right? With all these polynomials running around. So, lots of practice. I'll let you get to it.